Hello, and welcome back to another episode with It's Dr. Dan. And today we're going to be learning about how to balance chemical reactions. So, when it comes to chemical reactions in your chemistry class, this is when things really can get a little overwhelming, but I hope that this video will help a little bit for you to be able to learn the basic process. So, what is it? What is a chemical reaction? So, the whole idea behind it is that it's a process when you have substances that are reacting with each other. So when this happens, bonds are going to be breaking and new bonds are going to be forming. So we're going to create brand new substances. So we're going to see changes occurring, whether it's in the form of colors, gases, or maybe energy and heat being released. There are going to be a lot of things that we will observe and we can measure in the lab. So, one way that we illustrate this is that scientists like to use chemical equations to represent these changes to see when chemicals are reacting. So, the basic way that this is actually going to be shown is that on the left-hand side of an equation, we'll write all of our reactants. And what that's going to be showing is we're going to, instead of writing like an equal sign, we're going to write an arrow saying that this is going to be yielding or creating different products. So we go from reactants to products. So what's participating and what's being created. Now, when we are looking at these different reactions, the whole idea behind it is that we have to conserve mass, meaning that whatever you are putting into the reaction, it must come out in the form of matter. This is one of the laws of science. So in a sense, the mass of the products must equal the mass of the reactants. Now, are we going to be like whipping out a balance and trying to see are we creating the same amount every time? Well, no, we're not going to be doing that. But what we can relate mass to is molar mass, meaning grams over moles. So, in a sense, this tells us that the chemical equations must be balanced and that the number of moles of each element on the left side must equal the number of moles of the elements on the right side. So we must have the same number of each atom on both sides. So that's the idea. So what's our agenda for today? So we're going to be writing out a bunch of different chemical equations. So we're going to first write out the unbalanced equation. We're going to count the number of moles, aka the number of atoms of each element on both sides. And then we're going to be multiplying these elements by coefficients or whole numbers, so whole number integers, to try to balance them on both sides. So let's try to do that. Let's go through a couple of different examples of how to really showcase this. So if I do, let's say the first one here, and I have H2 reacting with O2 to create water, how would I balance this equation? So the first thing you're going to do is you're going to have an imaginary divide right down the middle, right? So it has to be the same number of reactants and the same number of products. So what we're going to do is we're going to write out each species that we have. So we have hydrogen, which is one element. Then we have oxygen on both sides. And now what we're going to do is we're going to count them. So we can see from the subscript on hydrogen, we have two hydrogens on the left. We have two oxygens on the left as well. Now, when we go to the right-hand side, we'll see that, okay, well, we have two hydrogens and one oxygen. And I like to write these numbers under the species that we're counting it from, so that way we can keep a little bit better track of our math. All right, so the goal is to make it the same number of moles equal on both sides. So what this is kind of showing for ourselves to draw it is that I have currently a hydrogen and it's reacting with an oxygen. So we'll draw them as little orbs. And what that is creating is essentially creating a water molecule. Okay, so that is what is happening here. So we have one orb reacting with another to create a new thing. So reactants go to products. So let's try to balance it. So the first thing you're going to think is, oh, I got to multiply the right side by 2. So this is a coefficient. So the way that we will show a coefficient is we put a number out front. So what this is telling you is that when you multiply that by 2, it's the same way as you saying that, oh, I have 2 water molecules that are now on the right side of the equation. So we have a total of 2 of them. So is that a balanced equation? Well, we didn't only multiply the oxygens, we also multiplied the hydrogens by putting that coefficient there. So now we have a total of 4 hydrogens on the right, 4 oxygen, or sorry, not 4 oxygens, 2 oxygens. So now we need to balance our hydrogens. And the way that we can do that is by adding a 2 in front of that hydrogen. So adding that multiple. And what that's going to do is essentially tell us that, oh, we have 2 hydrogen molecules reacting with every 1 oxygen molecule. So in a sense, this is like saying we have 2 moles of H2, 1 mole of O2 creates 2 moles of H2O. And that's the idea behind chemical equations. This is all balance in terms of elements. Let's try another one together. So if I do another, let's say we have zinc is reacting with HCl, and what that's going to be creating is zinc chloride and a hydrogen gas. Now, one other thing that we can do with chemical equations to tell just something else your teachers are going to make you do is you have to label what phase everything is. So if it's a solid, we put an S. If it's aqueous, or meaning it's a liquid in a solution of water, that's AQ. Or if it's like a liquid, we'll use an L for liquid, but none of these are just pure liquids. Or if it's a gas, we use a G. So I would get in that habit just because it will help you be able to figure out what you're going to see. Okay, so what is this really showing? So we have a zinc atom, and that's going to be reacting with, we have hydrogen and chlorine. So that's going to be reacting with an H with a Cl. So we should do Cl as green. So these are going to be reacting with each other. And it's going to be creating a zinc chloride. So we're going to have a ion here that's being made. Okay, and then we're creating H2. So are we balanced on both sides? Well, let's count. So we have 1 zinc, 1 hydrogen. I'll put that in the right spot for ourselves. 1 chlorine. We have 1 zinc and then 2 chlorines looking through this. And then we also have 2 hydrogens going through this example. So one thing you're going to see really quickly is the H and the chlorine are not balanced. We have 2 on the right-hand side and 1 on the left. So as a result, what should we do to balance it? Well, a quick thing that you could do is, oh, we should probably multiply these by 2 to show that, oh, this is going to be balanced on both sides. So we can see the zincs will be balanced, the hydrogens will be balanced, and the chlorines will be balanced. So if I add a 2 here, that is now going to be balanced. So how can we illustrate that? Well, it's the same thing as saying that, oh, I have 1 zinc atom reacting with 2 HCl molecules to create 1 zinc chloride and 1 H2. So it's the same way as if moles, being that in stoichiometry, you'll have to do moles. This is 1 mole of zinc, 2 moles of HCl, 1 mole of zinc chloride, and this is from the coefficients, and then 1 mole of H2. So it's a way for us to illustrate all those little different pieces to make it a little bit easier. Okay, let's do another. So if we want to do one that might be a little, let's do 2 little harder ones. So if I have sodium hydroxide reacting with magnesium nitrate, and that is creating sodium nitrate and magnesium oxide. Okay, so we have this problem. First thing what we're going to do is we're going to list out all the different starting pieces. So we have sodium, we have magnesium. Now, this is one of my biggest tips. Notice how we have polyatomics in this part of the problem. What do I mean by a polyatomic? Is that we have hydroxide, which is a polyatomic. And then we also have nitrate, which is a polyatomic. Write them down as one unit or one species when balancing. It's going to make your balancing life a lot easier. So we're going to write down our polyatomics. So with these, make sure that you are able to recognize when you have a polyatomic. I'm going to show you why here in a second. So when we go through the balancing, let's count what we have. So we have 1 sodium, we have 1 hydroxide, we have 1 magnesium, then we have 2 nitrates. And the way that we have 2 nitrates is by looking at the little 2 that's outside of nitrate, and that's how we know we have the 2 there. So on the right-hand side, I have 1 sodium, 1 nitrate, then I have 1 magnesium, and then 2 hydroxides. Okay, how can we go through and balance these? So the first way to balance these is start with the polyatomics. And what we're going to be doing is what I refer to as the zigzag method. So how does that start? So if we start, let's go with we'll start with the hydroxide on the left-hand side, just because it's the one closest to the beginning. So if we start right here, what we're going to be doing is balancing those hydroxides. So we had 2 on the right, so we need to multiply this by 2. So we'll add a 2 out front. This also multiplies a 2 in front of the sodiums. Now, when we have that, and let me move that 2 over because I'm realizing I'm getting cut off, is when we have that, we're now going to go to what it's connected to. So we're going to zigzag to what it's connected to, meaning we're going to check the sodiums now. So sodium, there's 2 on the left. There's only 1 on the right. So how do we balance that? Well, we need to do the same thing. We need to add a 2 on the right. Now, when we do that, we're now going to zigzag to our nitrate and try to balance those. There's only 1 nitrate on the right-hand side. There's 2 on the left, looking at those 2. So we already multiplied the one on the right by 2. Notice how they're now balanced. And as a result, as you keep zigzagging from its partner across back and forth, everything else ends up balancing as well. So it balances out the whole problem for yourself. This is one of the biggest hints with polyatomics. I couldn't recommend this anymore when you're going through this. Let's do one more, which is a combustion problem. So combustion reactions can sometimes be very tough to do. So what this looks like is that you're always going to have some kind of hydrocarbon, and it's going to be reacting with oxygen to create CO2 and water. So with these, the big problem is that we have multiple sources of oxygen on the products. Notice how we have oxygen here, and then we also have oxygen over here. So it leads to this weird imbalance between them. When you have that, my big suggestion is try to make them even, meaning when you're adding them together, notice how with the oxygens I have 2 plus 1 here, make the overall total even. It generally leads to more likely you're going to get the correct answer by doing that. The other big thing with a lot of these types of problems, if it's not balancing correctly, meaning that you have to use a fraction to balance it, then you most likely have to multiply the beginning large hydrocarbon over here by a factor of 2 or 3 to balance it. So let's try to do something simple. So the first thing that I would do is if I were to try to balance out these oxygens over here, we want to leave oxygen for dead last on the left because it's by itself. Use it as a kicker. Leave elements for last. And that way you can always use it as your final step. So the first thing I would try to do is balance the hydrogens. So if I do that with the hydrogens here, notice how with oxygen, it's going to be making it an odd number to balance out the number of hydrogens on the left for the total number of oxygens. So we have 2 plus 3. This already is setting you up for failure. If that happens where you have an odd number of oxygens, start over and multiply that first number by 2. Save yourself the pain and agony now, multiply it by 2. So what that means is if we had 2 hydrogens at the beginning, or 2 carbons at the beginning, we're multiplying that by 2. We're also taking the hydrogens, multiplying that 2 for a total of 12. So we have a lot of them. Now we can go through and try to balance our problem. Okay, let's start with the carbons first. Carbon is always a good one to start with. So I have 4 on the left. I need 4 on the right. So when we do that, we now have a total of 8 oxygens plus 1, so 9, 4 carbons. Carbons are balanced. Next thing we're going to do is we're going to balance the hydrogens. So being that we are working on this part of the problem over here. So we have a total of 12 on the left. So we need a 6 in front of that hydrogen to make a total of 6. And then we'll also multiply the oxygen by 6. Notice how I made this into an even number. So it's 6 plus 8, total of 14, total of 6, total of 4. And then on the other side as well, we have a total of, I just realized I did some math wrong. It's total 12, 12 and 4 over here. Now with the oxygen's the last thing. So that's why I said save that element for last. So being that we already have 2 oxygens on the left-hand side, how could we make it balanced for ourselves? Well, I need to multiply it by a 7 to balance it. So leave your elements for last. Okay. Now, if you were to start this problem, and let's say you notice, let's say you multiplied that first number a little prematurely, and you can see that everything is divisible by a whole number, so maybe it's divisible by 2 or 3, you can divide all your coefficients. So you want to make sure you have the smallest whole number ratio for coefficients. So keep that in mind for yourself, as you always want to have the smallest whole number ratio. So for example, let's say if I had 2, let's just make up a fake thing. Let's say I had 2a, 4b, and that made 2ab squared. And that's what that made here. Well, if that created that, well, we can divide all of these by 2 to simplify these. So if that's ever the case, make sure that you're always double checking you have that simplest whole number ratio. I know there's a lot of things that we're all learning at the same time, but keep that in the back of your mind. So this is just a tip for yourself. Now the other big tip is you're just writing coefficients. It's the same idea as how I was drawing these earlier, saying like as their individual molecules. We're not actually carrying out math on these things. So what I mean by that is, let's say if I take the 2HCl that I had here earlier, and we'll go back down. So if I have that 2HCl, we're not going to carry out the math on that and make it H2Cl2. Like that is not correct. So coefficients just tell you that you have a total number of molecules. So what that is that we have 2 HCl's in this particular problem. So that's another tip with that. We're just adding up different mole values when we're counting these. Okay, so this is my video on how to balance chemical equations. If you need, I will be making more on types of chemical reactions in the near future. And I hope that this video helped, and I hope to see you next time. Please consider hitting that subscribe button so you get some future videos and help. And this has been Dr. Dan, and I'm really excited that you're stopping by for help. All right, see you all later. Bye-bye.